AMCASH, Advanced Materials Characterization Simulation.
As a part of the AMCASH demonstration series, this talk will look at contact-based thermal monitoring using thermocouples and a data logger. My name is Richard Turner. I'm a research fellow at the School of Metallurgy and Materials at the University of Birmingham. So what is a thermocouple? Well, it's an electrical device with two dissimilar electrical conductors inside it that form an electric junction. It uses the thermoelectric effect to produce a temperature-dependent voltage. And if we measure that voltage and we know the temperature dependency of the materials in the thermocouple, then we can back calculate the temperature that it was at. It can therefore act as a probe to determine the temperature of an object or an atmosphere that it's in contact with. They can be made of different combinations of two materials, and they will have different range capabilities depending on the materials used. The most commonly used thermocouple is the K-type. It's cheap, it's got a really good operating range of minus 180 degrees Celsius to 1150 degrees Celsius. They can be sheathed to improve their rigidity, and so long as that electric junction remains in contact, then they're completely reusable. And so what is a data logger? Well, very simply, the data logger is an electronic device that interprets the voltage outputs from the thermocouples and converts that to a temperature reading. They can be handheld devices which have a digital display on them, as we can see, and this would give you an immediate result. They can be a signal box which syncs with the PC, and that would store the data as a TXT file on the PC, and that gives us various graph plotting options. We can set up our thermocouple and our data logger to allow for automatic thermal data acquisition of your desired process or object or atmosphere. A data logger will have multiple channels. We can change the acquisition rate from maybe a fraction of a second to hours. We can change our acquisition time from as small as you want to as long as you need. So if we compare contact-based thermocouple measurements to a technology like infrared thermal imaging, we do have infrared thermal imaging capability on the project, and there is a separate video on that if you're interested. But contact-based measurements using thermocouples are a bit more fitting to set up than the contactless IR technology. However, with a contact-based thermocouple, we don't need to have any previous knowledge of the emissivity of the material, in which you would need to do for infrared technologies. Thermocouples have got a good accuracy. They're quoted as plus or minus 1.5 degrees down at lower temperatures, increasing to about plus or minus 4 degrees up at the higher temperature capability that they can measure. And contact-based thermocouple measurements offer a really great thermal measurement method for all industry sectors, so long as the contact with a foreign object isn't a problem for your component. And so if we think about what industrial uses we could have for thermocouple measurements, then perhaps a feedback system to monitor the temperature within a heat treatment furnace. We could look at having systems to monitor manufacturing tooling temperature during a manufacturing route. We could monitor the components during a manufacturing route. We could monitor the temperature of a component as it's in service and see if there are any performance issues there. Or we could look at standard environmental temperatures over a given time frame. And so that concludes the contact-based thermocouple measurement talk. If you've any interest in using any of the equipment that AMCASH can offer, then please do get in contact with myself or with the AMCASH project team. Thank you very much.